Hello everyone, I'm Amit Bhuptani, Assistant Professor in Mechanical Engineering Department at Dr. Subhash Technical Campus, Junagadh. I welcome you all on today's presentation related with the subject Industrial Engineering. In our today's discussion, we will study about the topic that is Statistical Quality Control. So before we begin our today's presentation, let us have an overview of today's presentation. The first topic that we will study, that is definition of SQC or Statistical Quality Control. Second topic, that is programs of SQC, and third, tools of SQC. So let us begin with our first point of discussion, that is definition of SQC. So what is Statistical Quality Control? As the name itself suggests, it's a quality control technique which uses some statistical tools for controlling the quality of products. It performs the inspection, testing and analysis to conclude whether the quality of each product is as per the laid quality standard or not. So it's a technique which is used to control the quality of the product by using some statistical tools or some techniques, which is ultimately used for controlling the quality of the product. And it is also used to check whether the quality of each product is as per the laid standard or not. So this is statistical quality control. Then it makes inspection more reliable and at the same time less costly. It controls the quality level of the outgoing product. So statistical quality control is a technique which utilizes the statistical tools to control the quality, to maintain the quality of the products, and makes inspection more reliable. This statistic quality control gives more reliable results. Its inspection is more reliable. Or it can be defined as a quality control system where statistical techniques are used to control, improve and maintain quality. You can define it that way also. Okay, it's a tool or it's a technique which is used to control, which is used to improve and maintain the quality of the products that is been manufactured. So it utilizes statistical tools and that will control the quality of the product. So this is all about definition of SQC, that is statistical quality control. Next topic of discussion, SQC programs. So a successful SQC program is supposed to give the following results that we will discuss one by one. How this, if you are implementing this technique SQC in your industry or in your factory, then what are the results it is supposed to give, or what is expected from this. We will see one by one. Improvement of quality, yes, quality of your products will improve. Reduction of scrap and rework. So scrap means wastage is reduced and reworking is also reduced, so that will ultimately help to increase your production rate. Efficient use of man and machines. Whichever machines you are using, you are efficiently using your manpower and machines. Then economy in use of materials, yes, less material will be used if you are implementing this. Removing production bottlenecks, yes, bottlenecks means suppose there are 5 machines and production rate of 4 machines are higher, but due to low speed of production of one machine, ultimately production rate is decreasing or it is affecting the production of the company. So that bottleneck is removed. Decreased inspection cost, yes, reduction in cost per unit. Scientific evaluation of tolerances. What are the tolerances that are provided, that is scientifically examined and accordingly the parts will be finalized. Then scientific evaluation of quality and production. So there are usage of some scientific tools. Reduction in customer complaints, because this ultimately this statistic quality control program or technique is mainly concerned with controlling the quality of the product. So by taking necessary corrective actions which are required, that they are taking, and they are trying to reduce those complaints. They are trying to reduce minimum error. So ultimately the complaints from customers is also reduced. There will be satisfaction among customers. So SQC program is nothing but you are supposed to expect if you are implementing this program in your factory. Next topic of discussion, tools of SQC. So principal tools that statistical quality controls that are using. The first is control charts for measurement and attribute data. Control charts for measurement and attribute data. So what is that? That is the first tool. And second, that is acceptance sampling techniques. The second tool that they are utilizing, that is acceptance sampling techniques. Acceptance sampling technique. So we will see one by one. Control charts. Okay, what is now control charts? What information this control charts gives? So it's simply a graphical representation or display of simple graphical display which is used to plot observed values versus time when the observations are made. So control charts is used for showing the graphical display of the observed values versus the time when during the observation, whatever things they are observing, that is plotted with respect to time. The primary purpose is to indicate when production processes might have changed sufficiently to affect product quality. So it also examines or also keeps track of the processes, production processes. Okay, either they have changed sufficiently. If they have changed sufficiently or in more amount, then the quality of the product is affected. So it keeps an eye or it indicates when the production process has moved or when it has diverted. If the indication is that product quality has deteriorated, corrective actions is taken. So with the help of this control chart also, if the production capacity if the production quality of the product is deteriorated, means it has been producing, the production process has been producing poor quality products, then corrective actions that must be taken. So it gives you an indication that you must take some corrective actions to improve the quality of the product. Compare attributes or variables of the sample with that of the standard. So what is attributes and what is variables? So one must have a clear idea of attributes and variables. So attributes is nothing but it measures the defective samples, or it identifies the number of defective samples within the lot. So that has to be examined properly, and variables are nothing but some dimensions in terms of length, diameter, weight, which can be measured with the instruments. So it compares with the standards with the help of control chart. Control chart for variables. It gives you a warning whether there is any variation from the desired level and shows the presence or absence of assignable cause of quality variation. So it gives you a warning whether the variation is from the desired level, whether there is less variation. If there is more variation, then that also it indicates. So it is used to indicate the variations which has been desired, whether it is around about that or whether it has moved from that. Then it monitors a different type of information. Then when the observed values goes outside the control limit, the process is assumed not to be controllable. So when there are certain control limits that has been said or that has been set, under which the parts must fall or the production process must give that quality product under that range, under that value, under that limits. So if it has gone outside that control limits, then the process is not controllable and production is supposed to be stopped. So, and then after, the employees are supposed to identify the problem and correct it. So there is a chart for the variable that is known as X bar chart. It shows the centering of the process and shows variation in averages of individual samples. It shows you the centering of the process, where the process is going on within that control limits, upper control limit and lower control limit. So it shows the centering of the process, how much there is variations in the average of individual samples. Next, control charts. Okay, sorry, I had gone back to the slide. Then X bar chart can be also known as mean chart. It monitors the changes in the mean of the process. We first need to construct in order to construct this chart, we first need to construct a central line, and to do this we need multiple samples and compute their means. So first of all, for drawing this chart you require to draw a center line, and then on the left and the right hand side there is limits, certain limits which has been set. So within, if the samples or if the items are falling within that control limits, then your part is acceptable. Usually these samples are small, which with about 4 or 5 observations. Each sample has its mean. This is the formula for control limits, which is used to calculate the mean value depending on the number of samples. To construct the upper and lower limits of the chart, we must follow the formula. This is the formula which is used for constructing upper and lower limits. This is all about control charts. So it gives you an information about the production processes, whether it is going away from the control limits, whether there are any corrective actions to be taken or not, whether that process is not controllable, then the production has to be stopped, whether the quality of the product is been deteriorated, then it must be stopped. So second tool that SQC uses, that is sampling inspection. So with the help of this technique, one can decide, or one can determine whether the lot of samples should be rejected or accepted on the basis of number of defective parts found in a random sample drawn from the lot. So in this method, suppose there are lot of 50 products, the products are 50 in lot of 50. So you are drawing one sample from that lot of 50 size, and based on that results, randomly you are drawing that, and based on the results you are deciding whether this lot is accepted or rejected. So if the number of parts exceeds a predefined level, the lot is, so there is some predefined levels that has been set, and if that is not met by the lot size of which you are doing the inspection, then that lot will be rejected. So sampling plan using attributes and variables. Sampling plan, what is single? In that we will study about single sampling plan. So here the lot is rejected or accepted on the basis of single sample drawn from that lot. Suppose the lot is of 50 product, and based on choosing any single product from that lot of 50, you are deciding on the basis of single sample drawn from that lot, whether this sample is acceptable or not. So steps used in this method is draw a single sample of size n. So the sample size may be either calculated or found from the table. Inspect the sample and find the number of defective components. If defective pieces exceed the acceptable number, suppose acceptable number is 5, if it exceeds, then the lot is rejected, and vice versa. So it must match to the predefined level or predefined standards or predefined acceptable number. It must satisfy that predefined acceptable number. If it goes beyond that, then that lot will be rejected, and vice versa. In case the lot is rejected, inspect each and every part a lot and replace the defective parts. So those defective parts has to be removed and replaced. Then second is double sampling method. In this method, if it is not possible to decide the fact of lot on the basis of one sample, then second sample is drawn out, and decision whether to accept or not is done on the basis of combined results of first and second sample. There may be possibility that first sample is acceptable and second is not acceptable. So here more number of samples are drawn, and based on that combined result you are deciding that this lot should be selected or rejected. So there are certain steps that double sampling method follows. That is, first step, that is determine number of defectives in sample n. Then next step, defectives do not exceed C1, then accept the lot. If defectives equal or exceed R1, reject the lot. If defective exceeds C1 but less than, then draw another sample and determine the number of defectives in second sample. So these are the conditions that are given that must be followed, and accordingly the samples are drawn from the lot. So this is all about sampling inspection. Thank you.